A very good morning to all and welcome to Pallavi Engineering College by H&S Department. We have completed Unit 1 Quantum Mechanics, Unit 2 Semiconductor Physics. Now we are discussing about the Unit 3 Optoelectronics. The content of this unit is radiative and non-radiative recombination mechanism in semiconductors, LED and semiconductor lasers, device structures, materials, characteristics, figure of merit of these two LED and semiconductor laser. Photodetectors, they are solar cell, pin diode, avalanche photodiode, and their structures, materials, working principles, and characteristics. These are the content it is of Unit 3 Optoelectronics. Now in detail, we will discuss about these topic. In lecture 1 of Unit 3 Optoelectronics, we are discussing about the introduction part and radiative non-radiative recombination mechanism in semiconductor. Opto means light, electronics, that is electron mechanics. Optoelectronics, it is a branch of physics where we are studying the study of light in electronics devices. Optoelectronic devices are the electrical to optical and optical to electrical transducers or instrument that is used such devices in their operation. Optoelectronics is the communication between optics and electronics, which includes the study, design, and manufacture of hardware. Device that converts electrical energy into light energy, light into electrical energy, semiconductors, through semiconductors. Optoelectronics is a specific discipline of the electronics that focus on light emitting or light detecting devices. Now let us discuss radiative and non-radiative recombination mechanism in semiconductors. Recombination mechanism is classified into two groups, radiative and non-radiative. Radiative recombination, it occurs when an electron in the conduction band recombines with the holes in the valence band and the excess energy is emitted in the form of a photon or a light. It is nothing but radiative transition of an electron in the conduction band to empty state, that is a hole in a valence band. The optical process associated with radiative transition is the spontaneous emission process, absorption or gain process, and stimulated emission. Stimulated emission of radiation is possible from the atoms in the metastable state. Spontaneous emission rate can be approximated by probability P equal to B and P, where P is the hole density, N is the electron density. Radiative recombination process B, R is the spontaneous emission rate. The current density due to spontaneous emission is given by Jr is equal to Qd into R, where Jr is the radiative current density and D is the active layer thickness. Pr, it is the spontaneous emission rate. Then let us learn about non-radiative recombination. An electron in the conduction band recombines with the holes in the valence band. The excess energy is emitted in the form of a heat in the semiconductor crystal lattice. Non-radiative recombination process increases agar recombination, surface recombination, recombination at defects. Agar recombination is usually the most important non-radiative recombination mechanism. Agar recombination process mechanism, energy versus momentum. Valence band and conduction band. Here the energy levels, light hole band and split off band. So this is the mechanism picture of a valence band and conduction band with the agar recombination. This process involves second conduction band electrons. First one, valence band holes. The agar recombination rate is PRY is equal to C agar n square P plus P0, where C agar is equal to agar coefficient, R agar is equal to C agar n square n plus P naught, because n is equal to P. In general, P0 is very less when compared to n. So R agar is equal to C agar n square into n. So R agar is equal to C agar whole power n cube. The recombination rate R RTR for classification of surface effect is proportional to eta and can be made calculated by RTR is directly proportional to N. RTR is equal to ATR into N, where ATR trap and surface recombination coefficient. ATR depends on the material's quality and the fabrication process. This ends lecture 1 about radiative and non-radiative transition. We will continue in the next lecture the remaining topic.